Okay, let's go ahead and look at a stress strain question. This is quite a tricky little beast, and the reference for this one is from Chapter 6 assignment that you handed in for me, and looking at question 2 from it. Now this one I took from the P.E.T exam bank, and it's quite a tricky little one, and usually when it pops up it causes people, for the most part, quite a bit of problems. So let's go through it and take a look at how we get to our final answer. Now I've gone ahead and drawn up a little diagram here for our steam piston inside of our cylinder connected here to our piston rod, and you can see on my diagram that the rod itself has a diameter of 4 centimeters in cross section, and the piston itself has a diameter of 20 centimeters. So to start off this question then, I've got to think really about what are they actually asking for. Well, the question is looking for the maximum allowable steam pressure, and that steam pressure is going to occur within the cylinder itself between the bottom of the cylinder and the position that the piston is in. And I want to know, so I don't exceed the allowable strength of the piston rod, how much steam pressure am I allowed to put in there? That's what it's asking me. So the first thing I would do then, once I've got a sort of handle on what they're asking me, is go ahead and write down what I've actually been given in the question. Well, I've already put down the diameters, so let's go ahead and list off here what our ultimate strength is. Now, strength and stress are pretty much interchangeable terms. So my stress ultimate is equal to 400,000 kilopascals. And the other value they're giving me is that the safety factor is equal to 12. Well, as soon as I see a safety factor in a question, I'm straight away thinking about the safety factor formula. And the safety factor formula is going to be equal to our ultimate stress divided by our allowable stress. Now again, if you prefer to use the words ultimate strength divided by allowable strength, then so be it, and that's fine. Now I've got in that formula, I've got the safety factor, and I've got the ultimate strength or the ultimate stress. So I can rearrange that formula to find the allowable stress or the allowable strength, or the way I'm thinking about it, I'm going to call it the working strength or the working stress. In other words, the stress that's actually on the rod when this thing is in operation. So let's do that. So rearranging our formula, my allowable stress is equal to my ultimate stress divided by my safety factor. So shoving some values into that now, my ultimate stress is my 400,000 kilopascals, and that was given in the question. We can now divide that by the safety factor that was also given in the question. That's now going to come down to be 33,333.333 kilopascals. Now that value there that we've just got, that is the actual allowable stress on the piston rod. So going back to our diagram here, the piston rod here, that's where that stress is going to be acting. And looking at my diagram, of course, that stress is going to then be transmitted through the rod down to our piston. So all we've got to do now is get into this problem by working from the top down of my diagram. So if I've got the allowable stress in my rod, I'm now thinking about using the stress formula. So looking over here, if I take my stress is equal to the load divided by the area, and I can now rearrange this formula to find the load. And again, this is the load on the rod. If I rearrange it for that, then it's going to be the stress on the rod that we just found multiplied by the cross-sectional area of the rod. So my stress, we found out over here, that was that number with all the threes. So that was 33,333.333 kilopascals. So let's pick that up with our exponential of 10 to the power of 3 for kilo, and now multiply this by the area. Well, the cross-sectional area is just going to be a circle, and the area of a circle is pi d squared over 4. Now, to keep this easier, let's convert the centimetres into metres right away. 4 centimetres in metres is 0.04 metres. We just have to move the decimal place 2 places to the left, as centis 10 to the minus 2. So sticking that into the circle formula, that'll be pi times d, 0.04 meters squared, and then divide that by 4. This now comes down on my working out to be 41.887 kilonewtons. And it's kilonewtons because I've just worked out the load on the rod, and the load's just a force. Well, once I've now got the load on the rod, that rod is connected to the piston, and now we can work out what's going to happen on that piston itself. Now, the question was asking for steam pressure, so I'm now thinking about what pressure is. Well, pressure is defined as a force per unit area. Now, the force I just found, that was this load here of 41.887 kilonewtons. The area, however, is going to be the area of my piston, because in the diagram now, I am now looking at this section under here where the steam pressure is going to be. And that steam pressure is acting on the area of the piston, not the piston rod. So let's make sure we use the right area here. So my force on top of my equation is 41.887 kilonewtons. So let's pick that up as 10 to the power of 3 divided by the area of my piston. Well, the area again is a circle, so I'm going to use the pi d squared over 4 formula. So pi multiplied by the diameter, well, the diameter of this piston here in my original diagram was 20 centimeters. There are 100 centimeters in a meter, so 20 centimeters in meters is 0.2 meters. Don't forget to square it and then divide it by 4 for our circle formula. If we now stick that through our formula, we come out with 1333.981 kilopascals, and that there is the maximum allowable steam pressure that I would allow on that piston to ensure that the load on my rod does not exceed 41.887 kilonewtons. And that is where our safety factor comes in. Remember, the safety factor is what's going to reduce your working load if the safety factor is increasing. And the whole idea of that is to make this machine safer to operate, so hopefully it doesn't break. Hopefully this one helped you out. It is a little tricky one, so watch out for this one if you're unlucky enough to come across it in the future. Great little question. I'll see you again for another question soon.